Hello again, you sick, twisted weather freaks. Welcome to another fun-filled, action-packed, and intellectually stimulating edition of This Week in Weather. I'm your host, meteorologist DT from weatherist.com, the Colonel of Confusion, the Captain of Chaos, the Commander of, well, Catastrophe. There you go. Knew I forgot one. It's a Sunday evening, 11:30. The new models are out. A lot to talk about, including the New England historic East Coast snowstorm and three other events coming up. Three of them, yeah. So the pattern remains active as we go into the last portions of winter. So let's get right to it. First, you really need to get the New England, about this New England historic snowstorm, and that's what a HEX stands for, Historic East Coast Snowstorm. You really need to get the Northeast Snowstorms books, the Volume 1 and Volume 2, by Paul Cosa and Louis Uccellini, you can see. Of course, Dr. Uccellini was just made director of the National Weather Service, so we actually have somebody in charge of Weather Service who actually cares about weather. I know, what a groundbreaking idea. And there's the great Paul Cosin as well. They're working on Volume 3 now, my understanding. I know this book by heart. I know it backwards and forwards. I know all the maps, all the events, and I update it every winter when the new data comes in and maps to save. And it's really important because you see things that other meteorologists don't see when you know the snowstorms this well. And let me show you exactly what I'm talking about here. This is the snowstorm maps from yesterday's, actually Friday, Saturday's New England blizzard. You can see, and notice what the point here is, that this very distinct line here with the heavy snow right in this area. And this is very common with systems that are Miller Bs. You can see that. Much less snow, very sharp delineation here. We can see that here. This is also the snowfall map through 7 a.m. on Saturday morning. Of course, there was additional snow in Cape Cod through Saturday afternoon, so that isn't exactly accurate. But again, you can see very sharp delineation here in the snow cover. The heavy snow did not get to Albany, as a lot of people forecasted it would, and did not get much past western New York, New Jersey, and Trenton. So it only had 4 or 5 inches down there. So not a surprise. Let me explain why. I use 3 different examples of Miller Bs. Miller Bs are snowstorms where the primary low moves into Kentucky or Ohio or Tennessee, and a secondary low reforms over the southeast or off the North Carolina coast, and that secondary low bombs out, becomes the major storm, often very intense storm. And that's exactly what we happened with this particular blizzard we had over the weekend in New England. Now, we have 3 different events here we can look at briefly, and I posted this in my analysis on the Facebook page and on the website. This is February 8th and 10th. This is December 30th and February 7th and 8th. And in all 3 cases, you can see very sharp delineation here in the snow lines. You can see in this area in here, right up in here, and again down here. Now, February 78th, the delineation was between D.C. and Philly. Here it was again right between Allentown. Look at the difference in Allentown and Philly and Trenton. And then here in February 69 snowstorm, Philly had 3 inches, New York City 20 inches, Allentown 5 inches. Again, very sharp cutoff. All 3 were famous Miller B snowstorms. And the northwest sides, all the forecasts got in trouble there. So because they didn't understand it. Now, this was the European versus the GFS from last Tuesday, which was 3 days before the event, Wednesday, Thursday, Friday, yeah, 3 days before the event, or 3.5 days. And you can see the Miller B very clearly. Let me point it out to you. You can see one low here and the other one there, and then they bombs out right here. You can see the storm. The GFS, meanwhile, shows no development at all and shows sunny skies 3.5 days before the event. It does not do well with East Coast storms at all. It never has, and it never will. This was the European ensembles. Same sort of thing. The European ensembles just crushes New England, swings it out here, as you can see. Here, 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 it goes like that. Big high to the north, like that. So there's your secondary low taking over on the Carolina coast. Classic Miller B setup. The European was very good. These are the snow maps. This was from February 6th. Again, you can see, notice here the trend. It's not actually important here. It's showing that there's a sharp cutoff in the snow on the western side of it. We all know this is going to get bombed, but the question is, was the heavy snow going to get to New York, to Trenton, to Philly, to Allentown? The European insisted it would not go any further than western Jersey, and it didn't. This is February 7th, a little heavier with the snow, but too much in New York City, but it got Connecticut, West Long Island, eastern Massachusetts perfect, as you can see. And again, it showed, look at this drop-off. 6 inches here. Oops. 6 inches here, 3 inches in Philly. Very sharp cutoff there. That's the important feature. All right. And then the GFS, here, look at this. Not a single location on the GFS. This was the 0Z Thursday run before the blizzard. Look, let me show you something. See all this? None of this is over 20 inches. It's all down 14, 15 inches. The GFS had no snow over 20 inches. I know, it's hard to believe, but it's true. That's exactly what it was showing. This is the NAM. This is the 4 kilometer WRF model, high resolution NAM. And you can see it had a little bit too much snow in Philly and New York on the western side of it, but the rest of it did a really good job with. This is the classic Miller B. This is the morning of February 8th, and you can see, actually midday February 8th, and you can see there's the secondary low, there's the primary low. This is now a dead low here. So this low dies out, and this becomes the big one. All right? That's exactly what happens. This is my first guess map. And this was the second guess map. I lowered the snow mounts all up in this area, as you can see. I had the 8 to 12 almost into Philly, and then almost towards Allentown. That was a little too high. And then finally, I just pulled that back a little bit. All in all, it was a pretty good forecast on my part. I didn't have a problem with that. I thought it worked pretty good. This was the rain. This was the radar now here at the middle of the storm on Friday afternoon. And what's important to notice here is we can see this area and then this area. Notice the very sharp delineation here of snow along the western edge. Look at that dramatic cutoff just west of Philly. And this is towards the evening hours. This is now 5 o'clock in the afternoon. 4 o'clock in the afternoon, excuse me. What's happened here is a lot of people are beginning to panic in New York City because they're seeing that the snow, you can see it right in here. See, it's cutting like that way. But we still have this to come in, and it's going to come in and save the day, and that's exactly what happened. But a lot of forecasts in New York City lowered the snow mounts, and when that piece came in, look what happened. The whole thing went boom over New York City. There was a huge expansion of snow in southeastern New York, and out all by Albany as well. You can see Albany here is all filled in. And even by 11 o'clock it moved very slowly, so it was all snowing in here. And of course a huge snow in this area, but that was not unexpected. That wasn't the issue. The issue was what was going to happen in North Jersey, New York City, and southeastern New York State. Alright, and this is not the first time this has happened. This is the European. We can take a look at this. Is Sandy versus, the GFS. Another serious ass kicking. This is the European back on, I guess this was October 23rd, 7 days before the storm hit. You can see the European just having a perfect track. Look at this. Oh my God, look at this track. Amazing model. And then this was the GFS out to sea. Yay! Out to sea. This was, even the NOGAVs had it, for Pete's sake. This is a high resolution European here from Weather Bell, folks, and you can see this is October 24th, which was 6 days before the event. It has a crashing into the Delmarva, southern New Jersey, which is pretty much what happened. So again, the superiority of the European on East Coast storms is just hard to beat. Now this is to talk about the February 13th and 14th event. The issue is how far north does the low go, and what the low level temperatures are going to be like. It may be too warm for a lot of places. Now this is the European model from this afternoon. You can see the low here. But the problem is we also have southeast winds a little bit. Now this is the rain snow line where the blue and the green meet. It's really far north. That's not great setup here for a lot of snow. And it moves off the coast, you can see, just like this. Boom. There you go. It goes out to sea. Now the problem is that this was the GFS on this morning, and midday, I should say, the 12Z run on Sunday. And again, it has good snow in southern New Jersey and Philly and Baltimore, D.C. I don't have a problem with that. I think if it's going to snow, that's probably where it's going to snow. But the model takes it south of New York City, Long Island, and Connecticut and Massachusetts. Not a total miss, as I've been saying, but most of the snow stays south of those areas. However, this is the new GFS in here. And you can see the new GFS is further north, as the rain snow line over D.C. and Baltimore, as you can see. And West Virginia gets a good snow out of it. And then it actually clocks New York City, Long Island, Connecticut, and southeastern Massachusetts with a decent snow. Not a blizzard, but they don't need a blizzard. They have tons of snow there. But several inches of snow would be a problem. Now, this is the GFS in terms of snowfall. It doesn't produce a lot, as you can see. Most of it's in New York City, up towards New York City, Philly, Washington, Baltimore. The NAM is much warmer. It's much further north, as you can see. Now, remember the blue line here, this thick blue line, this is the rain snow line. You can see that on the NAM. Look how far north it is. why is the NAM that far north? Well, we can take, and once it gets off the coast, the secondary takes over. The cold air manages to come back a little bit, and you have some snow over New Jersey and New York City and eastern Pennsylvania, Connecticut, and Massachusetts, and decent snow as well. The problem is it's the NAM, and it really sucks at this time range, and solution's wrong. NAM has a lot of snow. You can see up in here. You can see all the snow in this area, and it has it into southeast into Connecticut as well. But like I said, I don't think this solution is correct. And this is why. As you can see here, the NAM has the main shortwave over Kentucky. And what that does is it pulls the low, let me clear, it pulls the low that's here northward. See? This low here is like this, and you can see it's going driven this way. So here it's over Kentucky, and here it's over southwestern Virginia. That's the difference between the two models. February 16th and 17th, let's take a look at that one. This could be the Miller B. Excuse me, a big coastal storm, the Miller A. This is the Miller A. Sorry about that, it's a little late. This is the European model from this morning, and you can see the European model was developing some sort of low here on the coast, as you can see very nicely, and then it develops it quickly. A lot of cold air comes in behind it. You can see that. And then this is the afternoon run of the European. Again, a little stronger, a deeper low that goes right up the coast, as you can see here. Goes like this, as you can see, just like that. So the question is, where does the low form? We don't know. That's the issue. Is we don't know where it's going to form. It might form here. It might form here. Don't know that yet. But the potential certainly is there for a significant storm. This is the European ensembles from this afternoon. And again, it's got the low forming along the middle Atlantic coast. This is the afternoon. This is the evening GFS. And it has a low, as you can see. Let me enlarge this a little bit. Here you go, as you can see. Here you go. See, it's got the low here, right? And here's the problem: is that there may be another piece of energy right in here that the GFS is missing, and that would cause the low to develop closer to the coast. And obviously, as you can see, it's quite cold, as you can see. A lot of very cold air in here, so that's not going to be a problem. Then the GFS, look what it does. It swings it way out here. That's not correct, but that's what the model is doing. And then finally, it's February 21 to the 22nd. This is the European model, and the European model is showing a nice block here developing a negative NA over Greenland, a negative Arctic oscillation. We can see the flow here splits. You can see that right there. We get one flow here, the other flow there. And, of course, we have my famous 50-50 low. So that's got potential as well. I don't think that should be overlooked. And this is actually the GFS, which is showing as well. Look here. You can see the GFS. See that huge storm there? Okay, there's our 50 low. It's up southeastern Canada. Now what that does is that pulls the cold air down, but see this storm here? Because of this one, it can't go there. It can only do this. And that's the potential. And you can see a lot of cold air over the east coast. There's the system at 850. There's the surface low right there. There's our big high coming down. So this also has the potential down the road. We'll see if it happens, but that's got the potential. Anyway, that's what we look at for the next 2 weeks. I'm meteorologist DET. I'll talk to you soon.